So a lot of times we start off with a quadratic equation in standard form, but we want to convert it to vertex form so that we can identify the vertex and graph it or find the minimum or maximum values. We're going to use a strategy called completing the square to turn a vertex form equation to turn a standard form equation into a vertex form equation. Now, this is going to require us to remember our perfect square trinomials and how to factor those. Remember that a perfect square trinomial is when we have some sort of a binomial that is squared. It could be two terms that are added together and then squared, or two terms that are subtracted from each other and squared, but it involves squaring a binomial. And if you notice in the vertex form equation, our x minus h, that is a binomial squared right there. So we're going to be able to use perfect square trinomials, do something called completing the square to our standard form equation in order to turn this into a factored perfect square trinomial looking like the vertex form. And we're going to need to remember this, b over 2, that entire quantity squared. That is going to be the value that we add in order to complete the square, and you'll see what I mean in just a moment. So, determine the vertex of the quadratic function below by completing the square and writing the function in vertex form. Okay, here we go. We have y equals 3x squared minus 12x plus 21. We're going to want to somehow turn these two terms into a perfect square trinomial, and this will end up being related to our k, or our y value of the vertex. Now, we got to factor out the 3 at the beginning of it because it's hard to find our perfect square trinomial otherwise. So we can turn this into y equals 3 times x squared, and negative 12 divided by 3 is negative 4x plus 21. Next, in order to complete the square and turn this into a perfect square trinomial, we have to add some value over here that is going to equal b squared at the end, as well as turn this into the value of 2ab, if you remember our perfect square trinomials. And that value that we're going to add, that value is b over 2, the entire thing squared. So our b is this 4 over here. 4 divided by 2 is 2, and square all of that. That gives us 4. So we're going to add 4 to the amount in the parentheses. So let's rewrite this, adding the 4. So that gives us y equals 3 times x squared minus 4x plus 4 plus 21. Now here's the thing, we can't just randomly add that 4 and leave it the way it is, because then we've changed the equation. Since we added it, we have to subtract it later on over here as well. We're going to have to subtract it, but we're not just subtracting 4 because this is really 3 times 4, which is 12. So we're going to subtract 12 from the end of this equation to keep the actual equation the same. Now this gives us y equals 3 times, then we have our perfect square trinomial over here, which is the same as saying x minus 2 squared, if you remember how to factor our perfect square trinomials, and then we work this out. 21 minus 12 is equal to 9. So now we have this equation over here, y equals 3 times x minus 2 squared plus 9, and this is in vertex form. We have our x value of the vertex is our 2 over here, and our y value is the 9. And just to make sure that this really truly does work, let's take this and expand it and make sure it equals our original equation. So if we expand it out, we get y equals 3 times x minus 2 times x minus 2, that binomial squared, plus 9. And if you square it out, if you distribute and square it out, you get 3 times x squared minus 4x plus 4 plus 9, which equals 3x squared minus 12x plus 12 plus 9, which is 21, and that is our original equation up here.